Question 1. Solve the inequality 3x minus 5 square minus 3 over 2 square is greater or equal to 0. Does the format of the inequality looks familiar to you? You probably can see that it is the difference of square. Recall that the difference of square can be factorized by using difference of perfect square, meaning a square minus b square can be factorized into a plus b, a minus b. We will be using this property to solve this inequality. 3x minus 5 square minus 3 over 2 square is greater or equal to 0. We factorize it. We have 3x minus 5 plus 3 over 2, 3x minus 5 minus 3 over 2. Simplify it, we have 3x minus 7 over 2, 3x minus 13 over 2 is greater or equal to 0. When 3x minus 7 over 2, 3x minus 13 over 2 is equal to 0, x is equal to 7 over 2 multiplied with 1 over 3, which is 7 over 6. And also, x is equal to 13 over 2 multiplied by 1 over 3. That will give us 13 over 6. Then we sketch the graph. This is our x-axis. We have a positive x square. Therefore, it is a smiling curve. The x-intercepts are 7 over 6 and also 13 over 6. We are looking for the range of values of x that is greater or equal to 0. It will be the area above the x-axis. Therefore, the range of values of x that satisfy the inequality is x is lesser or equal to 7 over 6, x is greater or equal to 13 over 6. Question 2. Find the smallest integer value of k for which 2x squared plus 5x plus 3k is always positive for all real values of x. We have the expression 2x squared plus 5x plus 3k. The expression is always positive for all real values of x indicates that y is always greater than 0, meaning it does not have real root. Therefore, b squared minus 4ac is lesser than 0. From the expression, a is equal to 2, b is equal to 5, and c is equal to 3k. Substitute a, b, c into b squared minus 4ac lesser than 0. We have 5 squared minus 4 multiply 2 multiply 3k is lesser than 0. Simplify the inequality, we have 25 minus 24k is lesser than 0. We continue to solve the inequality. Negative 24k is lesser than negative 25. K is greater than negative 25 divided by negative 24. Remember to flip the sign when we divide a negative number. Further simplify the inequality, we get k is greater than 25 over 24. We are asked to find the smallest integer value of k. Therefore, k is equal to 2. Question 3. The operating cost of a company can be approximately modeled as Cx equal to 17 minus 8x minus 2x squared, where x is the time in years. Given that its revenue function is Rx equal to 5 minus 3x, find the number of years during which the company is not making a profit. The information we have are Cx is equal to 17 minus 8x minus 2x squared. And also Rx is equal to 5 minus 3x. We are asked to find the number of years, which is the x, during which the company is not making a profit. In order for the company not making a profit, the operating cost must greater than the revenue. Hence, the revenue minus the cost is a negative number. Let's substitute in the function 5 minus 3x minus 17 minus 8x minus 2x squared is lesser or equal to 0. We expand the bracket. We have 5 minus 3x minus 17 plus 8x plus 2x squared is lesser or equal to 0. We simplify the inequality. 2x squared plus 5x minus 12 is lesser or equal to 0. We factorize the inequality. 2x squared can be separated into 2x and x. For 12 can be separated into 1 times 12, 2 times 6, 3 times 4. Let's try 3 and 4. Here we will get a 3x. For this one, we will get a 8x. 3x and 8x, we add them, we get a 11x. If we minus them, we get a 5x. In order to get a positive 5x, we minus 3x, add 8x. Minus 3x and add 8x. And lastly, we need to check negative and positive, we have a negative. When 2x minus 3, x plus 4 equal to 0, x is equal to 3 over 2, and also x is equal to negative 4. We sketch the graph. This is the x-axis. We have a positive x squared, so it is a smiling curve. The x-intercepts are negative 4 and also 3 over 2. We are looking for the range of values of x where the inequality is lesser or equal to 0. That means we are looking for the area below the x-axis. The range of values of x that satisfy the criteria is x is between negative 4 and 3 over 2. We look back at the question again. We need to find the number of years which the company is not making a profit. Therefore, from the range of values of x, we can interpret that x cannot be a negative value because x is the number of years. So x must start from 0. And when the x is lesser or equal to 3 over 2, the company is not making a profit. When the x is greater than 3 over 2, the company is start making profit. Therefore, our answer is x is equal to 3 over 2. Question 4. A gardener is laying out a rectangular lawn. His specifications are that the area must be greater than 40 meters square, but the perimeter must be less than 40 meters. If the width of the lawn has to be less than its length, find the range of possible values for the width of the lawn. Here we have a few pieces of information. The first one, area must be greater than 40 meters square. Area is greater than 40. Can also written as width multiplied with length is greater than 40. Second piece, perimeter must be lesser than 40. Perimeter is lesser than 40. Can be written as 2 bracket width plus length is less than 40. We simplify it. We will get width plus length is less than 20. And the length is less than 20 minus the width. And the third piece of information, the width of the lawn has to be lesser than its length. Width is lesser than length. The first piece, the second piece, and the third piece. First, let's combine all the information. We start from the third one. Width is less than the length. And we know that width and length both must be greater than 0. They cannot be a negative value. The second piece of inequality states that length is lesser than 20 minus the width. We can combine this piece of information into here. We need an inequality for the area as well. Let's start from the second piece. Length is lesser than 20 minus the width. We multiply both sides with the width. And we know that area must be greater than 40. We can combine it over here. Let's look at the side note. If A is lesser than B and B is lesser than C, we can say that A is lesser than C. Same for this inequality. 40 is less than the area, where the area is less than W multiplied with 20 minus W. We can say that 40 is lesser than W multiplied with 20 minus W. We continue from here. 40 is lesser than 20W minus W squared. We bring all the terms to the left side. We get W squared minus 20W plus 40 is lesser than 0. Before we can find the range of the possible values for the width, we need to find the intercept first. When W squared minus 20W plus 40 is equal to 0, this quadratic equation cannot be solved using factorization method because none of the combination will give us 20. Hence, we have to use other method to solve for this equation. Let's use the formula. A is equal to 1, B is equal to negative 20, C is equal to 40. W is equal to minus B plus minus square root B squared minus 4AC divided by 2A. Simplify the equation, we will get 20 plus minus square root 400 minus 160 over 2, which is 20 plus minus square root of 240 over 2. Square root of 240 can be written as square root 16 multiplied with square root 15. We further simplify it, we will get 10 plus minus 2 square root 15. Therefore, the roots for W is 10 plus 2 square root 15 and also 10 minus 2 square root 15. After that, we sketch the graph. This is the inequality. We have a positive W square. So it is a smiling curve. And it cuts the axis at 10 minus 2 square root 15 and also 10 plus 2 square root 15. We are looking for the area where the inequality is lesser than 0, which means the area below the axis. Therefore, W is in between 10 minus 2 square root 15 and also 10 plus 2 square root 15. But we know that the length is lesser than 20 minus the width. when the width is equal to the length, we have width is lesser than 20 minus the width. 2 width is lesser than 20 and the width must less than 10 in order to fulfill the condition. Hence, we need to do some alteration for this part. And our final answer for the range of possible values for the width is between 10 minus 2 square root 15 and 10.